Hello, this is Mrs. Taylor, and I'm going to walk you through how to complete this activity so you can discover the transformations of an absolute value graph. So in the first section, we have 4 different functions. In the directions say choose 4 different k values and write new equations. And by k values, it means, if you look at the first worksheet, it's this equation here, and k is right here. And so basically we're choosing different values to add to the absolute value. And so it doesn't matter which ones you pick. I'm just going to go with -1. But you can pick whatever you want. And if you look down here, it says using 4 different colors graph each equation. So I'm going to use 4 different colors to write my numbers so I can keep up with, once I graph it, which number goes with which graph. Just picking some random numbers here, okay? And then from there, what I'm going to do is I am going to create a T-chart, or a table, to plot some points to graph this first equation for number 1. So the way I do that is I have an X column and a Y column. And it doesn't matter which values you pick for X. I mean, you're graphing this. It's your call. You can do whatever you want. However, it's always a good idea when you are choosing X values for a T-table to choose some negative and some positives. And so I'm just going to go -3, -4, or not -4, -2, -1, 0, 1, 2, 3. And then what I do is I take my first X value and I plug it in to my first equation, number 1, here. And so when I plug in my first X value, -3, it's going to look like this. The absolute value of -3. Let's clean this up a little bit so we can actually see what it says. So the absolute value of -3 plus -1. And when I evaluate that, the absolute value of -3 is 3, and 3 plus 1, or excuse me, plus -1 is 2. And then continue going, so -2, plug that in for X and number 1. The absolute value of -2 plus -1. Absolute value of -2 is 2 plus 1 is 1. And then I'll just continue that pattern of plugging in and finding the Y value. So now I have my whole T-table filled in right here. And all I did was plug in the X value and get the corresponding Y value. So when I'm plotting points, what it looks like is my X and my Y. So this would be -3, 2. And X and Y, so -2, 1. -1, 0. 0, -1. And continue down the table until you have all of your points right here. Okay? So then what I'm going to do is I'm going to plot these points. So if I want to plot -3, 2, start at the origin, go to the left 3 because it's negative, and up 2. And then my next point, -2, so the left 2, up 1. -1, 0 would be to the left 1 and not up anything. And then 0, -1, so 0, -1. 1, 0. 2, 1. And 3, 2. And then I would just connect those points to create my first graph. And so I would continue this strategy that I used here, plot these points, and use 2, 3, and 4 for my equations. If you notice a pattern, you don't have to continue plugging in values. However, if this works for you every time, then do this every time. By the end, you should get something that looks like this. A series of V-shaped graphs that are translating. So translate means to slide, or translating up and down the y-axis. So how does K affect the graph? It translates the function And I could say up and down the y-axis, or it's up and down, so that would be vertical. So it's a vertical translation. Now we're going to continue this strategy for the other two sections. Here they will be to choose values for h. You see it says find different values for h. And if I look at my worksheet and scroll to the general form for an absolute value function, h is this value here. So it's x minus h. So if I plug in some numbers, it doesn't matter which ones, whatever you want. But again, we're going to use 4 different colors. So I'm going to make this one 1, 2, I'm going to throw in some negatives, -4, and then -2. Okay, and then I'm going to create my t-chart, plot the graph. So the first thing I did was I chose some x values, -3 to 3, sounds like a good variety. And then I just took the x value and I substituted it in for x for number 1. And then just wrote out -1 and my absolute value bars for each of these. And so the key is when you have the expression inside the absolute value bars, you have to do what's inside first and then take the absolute value. So -3 minus 1 is -4, absolute value would be +4. -2 minus 1 would be -3, absolute value would be +3. This would become -2, absolute value would be 2. -1, absolute value would be 1. This would be 0. 2 minus 1 is 1. 3 minus 1 is 2. And then I would plot those points and create the line. And just remember, like before, this is my x value, this is my y value. So I'm finding point -3, 4. And then the next one would be -2, 3. And then end of line 2. And so on down the line. And once I plot my points, I have a V that's no longer centered on the y-axis. So this little change in direction of the line, this point where it changes from a decrease to an increase, this is called the vertex. And the vertex actually moved off the y-axis this time. It shifted to the right 1 unit. So let's see if that pattern continues. So I'm going to continue to graph these lines, or excuse me, these functions, and let's see what happens. So once I have everything graphed, I can see clearly that my V's are shifting left to right. So when it says, how does H affect the graph? Well, if it's sliding, that's still translation. And instead of up and down, it's translating left and right. So that would be a translation horizontally. So if I add or subtract something outside of the absolute value bars, it moves it up and down. If it's inside, it's moving it left and right. Okay, the last variable that we have to figure out what it does is A. And if I look at the worksheet, A is this number here outside of the absolute value bars. So it's going to be multiplied. And so, again, I'm going to make my t-table, or t-chart, or table, whatever you call it. And I'm going to fill it in. First I'm going to pick some numbers, and it says choose 4 different A values, 2 integers, and 2 fractions. Remember, integers are non-decimals. So I'm going to pick a -1, and I'm going to pick a +1. And then 2 fractions. So I'm going to go pretty easy here, and I'm going to go with 1/2. And let's choose a negative fraction, say -1/4. Okay? And now I'm going to plug this into a t-table. Now I'm looking ahead here, and I see I have a 1/2 and a 1/4. And I know if I have to multiply by a fraction, I'm either going to have to estimate, or if I choose x values that divide out nicely with those fractions, it might make my life a little easier. So instead of doing one of these, 1 and 2, I'm going to work through number 4 for my graphing purposes, just to give you an idea of how to make that easier. So if I have to multiply by 1/4, that's the same thing as dividing by 4. So I'm going to pick multiples of 4. And so I'm thinking -8, -4, 0, 4, and 8. Because if I divide each of these by 4, I get a whole number. So choose smart. You have options. Choose smart. Make your life easier. So if I plug -8 into number 4, this function here, I have -1/4 times the absolute value of -8. And the absolute value of -8 is 8, and 8 times 1/4 would be the same thing as 8 divided by 4, which is 2, but it's negative, so this would be -2. And then again down here, -1/4 times the absolute value of -4. The absolute value of -4 is 4 times -1/4. Well, divide by 4. 4 divided by 4 is 1, times the negative would be -1. And then by 0, well, that would be -1/4 times the absolute value of 0. Anything times 0 is just 0 times 4, or excuse me, absolute value of 4 times -1/4. That again would be -1. And then I plug in the 8, and I get -2 again. So again, these points would be -8, -2, -4, -1, 0, 0, 4, -1, and 8, -2. And the only way I got those was just taking my x and my y and putting them together. I'm going to plot the points and let's see what happens. Once I graph it, it looks like this. So it looks like it's been squished. Like somebody stepped on the top of it and it's squished. And not only that, but it's flipped upside down. So now I'm really curious about what the others do. So I'm going to keep going with my t-tables and figure this out. I made my t-table for 1/2 here, and when I plotted it, now it's flipped upright, but it still looks like it's squished. We're going to call that a compression, where it's compressed. So it looks like it widens it out, which would be a compression, and depending on if it's positive or negative, it looks like it's going to flip. Either it'll be upright or flip down. So let's see what happens with the whole numbers. Once I have all my graphs plotted, if I look, when I had a whole number, instead of it flattening out, it got more narrow. And what we call that is a stretch. It's like I took these two ends here and I pulled them up, so stretched it up. So that's called a stretch. And then when I had that -2, it flipped it upside down again. So to answer how does A affect the graph, well, it makes a stretch or compression. And we're moving up and down with that, so I'm going to write that as a vertical stretch or compression. And let's see, if it's positive or negative, it'll determine if it's up or down. So let's see, positive, negative determines if the V is up or down. So bottom line, in all of this, through graphing all these, I've now discovered that if this is the general form of a absolute value function, then I can look at that, and now that I've gone through all these different graphs, I can tell you what each of these does. This is a vertical stretch or compression. And it determines if it's V up or V down. So this would be positive and this would be negative. The H, remember that is a horizontal translation. So that means left or right. And then this would be my vertical translation. So that would be up or down. So those are what A, H, and K do to my graph of an absolute value function.